Good morning, everyone, and welcome to this lecture. This is lecture number one in a brand new topic, and the name of the topic is electric current. So, we had finished with the capacitance in the last class, if you can remember, and this is the new chapter, electric current. But you will see a lot of the things being exactly similar. So, we'll just go through them. So it would be again a revision of probably what we had done in the previous class or previous section. Current electricity. What do you mean by current? Anyone, any idea? Electric current. Electric current. And it is normally denoted by the letter capital letter I or small letter I. What do you mean by current? Anyone? What do you understand by current? When do we say current is flowing? Current is the rate of flow of charge. Do we understand this? Rate of flow of charge with time. In how much time, how much charge has flown, the rate of the flow of charge is known as current. Now, whenever we talk about charge, that must be the net charge that has flown. The net charge that has flown. So, whenever there is a flow of charge, the rate of flow of charge is known as current. I, current. What type of quantity is current? Current is a scalar quantity. All of us know this, yes or no? That current is a scalar quantity. We know this? Yes or no? Do we know this? Okay, no one is replying. I hope everything is okay. The SI unit of current is known as ampere. A ampere. Remember, current is one of the 7 fundamental quantities. One of the 7 fundamental quantities. Dimensions is A raised to the power 1 or M is 0, L is 0, T is 0. It's a fundamental quantity. It has its own dimension, and the dimension is A. Do we understand this? I'm not able to hear any one of you. Do we
Yes,
understand
sir.
this? Okay.
Yes, sir.
Noted? Have you noted this down, everyone?
Yes, sir.
Correct.
Yes, sir.
Okay. Well done. Now, whenever we talk about current, there may be two types of current that we may encounter. There may be two types of current that we may encounter. What are the two types of current that we may encounter? The first type of current that we may encounter will be known as average current. The first type of current that we may encounter may be known as average current. Now, what do you mean by average current? Anyone? What do you mean by this average current? Average current, you can write it as I in a box. Remember that box? Average is the box. This average current is delta Q by delta T. That means it is nothing but total charge. Total charge that has flown. 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 Total char divided by total time. Do we understand this? Total
Yes,
charge
sir.
divided by total time becomes your average current. Total charge divided by total time is your average current. Then we have one more current that you can call as instantaneous current. And the other type of current you can call it as instantaneous current. Now, when I say instantaneous current, it's the current at this particular time, at any instant. What is the value of current at this time? How much current is flowing through this tube light? That value at any instant is known as instantaneous current. And how do I find instantaneous current? I write instantaneous current like this, and I find the rate of flow of charge dq by dt. So whenever someone talks about current, you must remember that he may be talking about average current. But remember, whenever he talks about this average current, he will tell you beforehand that okay, find out the average current. When someone tells you to find out the average current, then only you find out the average current. Otherwise, whenever anyone says anything, what is the current right now? Well, when he's talking like this, what is the current right now? He is probably speaking about the instantaneous current. So, instantaneous current is the current that we use in our day to day life or language. Do we understand this? Instantaneous current and average current. Everyone understand this? Yes or no? No, yes.
Yes, sir.
Yes, sir.
Now, current is a scalar quantity, but current has a direction. Current has a magnitude, current has a direction, but it is still a scalar quantity. Now that's one thing that may be asked. Current is a scalar, but it has, and remember, it's a scalar quantity, but it has both magnitude as well as direction. So current is somewhat special. It is treated as a scalar, but it has both magnitude and direction. We have seen any quantity which has both magnitude and direction, it must be a vector, but current is not a vector. It is a scalar, even though it has magnitude and direction. And the reason for it being a scalar is it does not follow, it does not follow vector laws. It does not follow the law of vector addition. What do you mean by the law of vector addition? Well, if one vector is like this and the other vector is like this, and the angle is theta, I hope you remember, one vector is like this, other vector is like this, and the angle is theta. If you add these two vectors, the new vector ka magnitude will be a square plus b square plus 2ab cos theta. Do we remember this? Yes or no?
Yes, sir.
So that is how two vectors get added. They get added up by vector laws of addition, triangular law, parallelogram law. That is how vectors get added. But my dear friends, for this current, it does not get added like this. Current does not follow vector laws of addition. To add or subtract current, you can do it as a number. 5 ampere of current is flowing in this direction. 6 ampere current is coming from this direction. How much current will go in the next branch? If I ask you that, and I can do it here only. 5 amperes of current is coming from here. 6 amperes of current is coming from here. How much current will be there in this branch? Yes, 6 amperes are coming from here. 5 amperes coming from here. What would be the current in the third branch? It would be 11 amperes. So it does not add like vectors. We can just add or subtract current like numbers. And therefore, my dear friends, this is not treated as a vector but treated as a scalar. Do we understand this?
Yes, sir.
Have you noted this down?
Yes, sir.
Okay, so current is not a vector even though it has both magnitude and direction. Having talked about direction, let us now move ahead and see the direction of current flow. Let us write the next heading, and that will be direction of current flow. Now remember, current is nothing but the flow of charge or the rate of flow of charge. So, to find out the direction of current, what we need to do? We need to see in which direction the charges are flowing. Yes or no? No, yes.
Yes, sir.
We
Sir.
have to see. You have to see that you have to associate the direction of current as from the direction of flow of charges, and that is how it is exactly done. The direction of current, as you can see, is taken as the direction of flow of positive charges. Do you see this positive charges? This positive charges. And you can see this electric field. Positive charges will always flow in the direction of electric field, and that is taken as the direction of current. We call it conventional direction of current. Conventional direction of current. Whenever anyone talks about the direction of current, this is the direction that he is talking about. He is talking about the direction of flow of positive charges. Do we understand this? Do we understand this?
Yes, sir.
Whenever anyone is talking about the direction of flow of current, he is talking about the direction of flow of positive charges. Okay, so that is the conventional direction of current. But actually, current is not the flow of positive charges because positive charges do not flow. Positive charges do not flow. It is actually the negative charges that flow. So the actual direction of current is actually the direction of negative charges ka flow, but we do not take it as a direction. We'll always take direction of current as the direction of flow of positive charges, and the direction of flow of positive charges is always opposite to the direction of flow of negative charges. So whenever, and you can see here, if the direction of current is like this, the direction of electric field is like this, but you can see here, my dear friend, the electrons are actually moving in the opposite direction because the direction of flow of electrons is opposite to the conventional direction of current. Do we understand this, everyone? Yes or no? No,
Yes,
yes.
sir.
Everyone understands this?
Yes, sir.
We have noted this down. Yes or
Yes,
no?
sir.
Okay. Shall we move ahead?
Sir, 1 minute wait, sir.
Okay, I'll give you 1 minute. You can note things down. You can also draw this diagram if you want to, because we will be coming across these things um, very soon. What do we see here in this red thing? What do we call this pink thing that is here? Anyone knows this pink thing? That is known as the battery. Yes or no?
Yes, sir.
That is known as the battery, and current will flow like this. That is the direction of flow of current that is taken. I'll give you 2 minutes. Note it down. Then we move ahead. So we have understood the direction of current.
Yes, sir.
Okay. Now, uh, remember, how do you find out what is the current? Now we might encounter these questions, so we will write them as important notes. So you can write these questions as important notes, points as important notes. First note. And what is the first note that we are going to write? All these are questions that are going to come in your exam. This is the first question, first note, sorry. If n number of particles, and normally these particles are going to be your electrons. Anyone knows how much is the charge of an electron?
1.6 into 10
1
to the power
point.
of minus 19.
Yes. So if n number of electrons are passing per unit time, so your charge will become total charge. So your current will become total charge divided by total time. Do we understand this? Sometimes this is given as q amount of charge is passing per units per second per unit area. In that case, you have to multiply it by the area. Do we understand this? That is how you can get the current flowing through that conductor. Current flowing through the conductor is only total charge divided by total time. Sometimes they will give you charge per unit area per unit time. Sometimes they will give you charge per unit volume per unit time. So these are the two cases. If the charge is given per unit area per unit time, you multiply it by area. If it is given per unit volume, you multiply it by the volume and the number of charges that are flowing. Do we understand this, bacha, what I'm saying here?
Yes, sir.
Okay. Sometimes the charge may be flowing in a circle. If the charge is in a circle, then this is the formula. Remember this, I have seen lot of time this question come. So these are the three important points that you must remember about finding out the current that is flowing in a conductor. If it is moving in a circular path, you can write current as q divided by t. T is 2 pi divided by omega, 2 pi into r by v, and this is the way you can find out the value of current. Everyone understand this? Yes or no? No, yes.
Yes, sir.
Pakka?
Yes,
Anyone
sir.
has any doubts on this?
No, sir.
Remember,
No, sir.
we can expect a question from this, and therefore you must be able to find out the answer. Have you noted this down?
No, sir.
1 minute, sir.
Okay, note it down. Please let me know. Noted it down.
No, sir.
Shall we move on?
Sir, no, sir. Sir, please, 1 minute.
Okay, take your time, don't worry. So now we move ahead. We have understood this concept. Let us do a sample problem. And this is the sample problem that is coming up. 10 electrons are flowing per second from left to right in a conductor. Find the magnitude and direction of electric current. If you don't know the charge of an electron, the charge of an electron is 1.6 into 10 raised to the power minus 19 coulombs. That is the charge of an electron. I'll give you 2 minutes to solve this question. Everyone understands the question? Yes or no?
Yes, sir.
2 minutes you have to solve the question and give me the answer. So, anyone with an answer? How do we solve this question? Is it such a difficult question? Cannot solve? Okay. Can I do it? Such a difficult question, beta. Okay, I'll solve it for you. 10 electrons are flowing per second. So they are flowing per second. So we can find out the total charge which has flown per second. And then you can find out the current. So current is total charge divided by total time. It is given charge is flowing per second. So you just have to find out how much charge has flown in 1 second. 10 electrons, the charge on one electron is 1.6 into 10 raised to the power minus 19. How that much charge have flown in 1 second? So that is your current. So your answer is 1.6 into 10 raised to the power minus 18 amperes. That is the current that is flowing. Do we understand this? Do we understand this?
Yes, sir.
Was it so difficult to do? That is the current. Now, these electrons are negatively charged and they are flowing from left to right. So, what is the direction of current?
Right to left, sir.
The direction of current is right to left. It is opposite to the direction of. It is opposite to the direction of. It is opposite to the direction of electrons. Do we understand this? Yes or no? No, yes.
Yes, sir.
And everyone noted this down.
Yes, sir.
Yes, sir.
Okay, can you move on to the next question?
Yes, sir.
20 electrons flow in 5 seconds across a wire. Find the electric current I. 20 electrons have flown in 5 seconds across a wire. We have to find out the value of electric current that has flown in the wire. Can you tell me the answer? You must know the charge of an electron. I have not written it. I hope you know this. What is the current that is flowing in the conductor? Yes. What is the current that is flowing in the conductor? Anyone with an answer? How much current is flowing in the conductor? 20 electrons are flowing in the conductor, flow through a conductor in 5 seconds. What is the current? Yes, my dear friends. Can anyone tell me what is the answer for this one? Simple question. What is the answer, beta? I'm waiting. No one knows the answer? Is that so? Okay, then I will solve it for you. How will I find the current? Current is total charge divided by total time. Total charge in this case is 20 electrons. So 20 multiplied by 1.6 into 10 raised to the power minus 19. That is the total charge divided by total time is 5 seconds. So I can cut it. So that is your answer. I think it is 6.4 into 10 raised to the power minus 19 amperes. Do we understand this?
Yes, sir.
You are not able to do this, beta? Why?
Got it, sir.
Please tell me, na, beta, so that I understand that you are understanding it. Else, I will solve all the question like this. Okay, everyone understands this? Yes or no?
Yes, sir.
Okay, one last question. Question number 4 and 3. 20 electrons and 5 protons Remember, the charge on an electron and a charge on a proton are same. Electron is negative, proton is positive. 20 electrons and 5 more protons are flowing from left to right in a conductor in 3 seconds. You have to find the current in the conductor. What will be the current in the conductor? 20 electrons and 5 protons are flowing in the conductor in 3 seconds. You have to find out what is the current in the conductor. How are you going to solve this? Electrons from left to right. Proton also from left to right. What would be, first of all, tell me what would be the direction of current? Remember, 20 electrons are flowing and 5 protons are flowing. What would be the direction of current? Will it be from left to right or from right to left? Yes.
Right to left, sir.
Right to left.
Right to left. So that will be the direction of current. We understand this now. How much will be the current? Total charge divided by total time. How much is the total charge flowing? 20 plus 5, 25 or something else? Now remember, 20 electrons are flowing and 5 protons are flowing. So basically 5 protons will have to be cancelled. So the net charge that is flowing, how much is the net charge that is flowing? It is 15 electrons that are flowing. Do we understand this? Do we understand this?
Yes, sir.
That the net charge is 15, 20 electrons and 5 protons flowing in the same direction. So 5
8
protons.
into 10 to the power of minus 19, sir.
So everyone got this? Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Okay, we will go ahead with this topic. It's a simple topic, simple question. We will go ahead with the questions in the next class, that is tomorrow. Please come on time. Please find out your schedule. When is your class? Please come on time. We don't have time to spare. Do we understand this? We
Yes, sir.
understand this. Do we understand this, beta?
Yes, sir.
Okay, then I'll see you tomorrow. Take care. God bless you. Everyone understood what we have done in today's class?
Yes,
Yes,
sir.
sir.
Well done, bacha. See you tomorrow. God bless all of you. Bye bye.
Thank you, sir. Bye, sir.
Thank you,
Take
sir.
care, sir.
Bye, sir.